See if what I write is a good kind of capper for what you wrote today. The first one, if you do your prime factor, is yes, ma'am. I understand. Yeah, you can go. If you're going to do the prime factorization here, this is 2 times 3 times 3 times 3. And the x cubed is x times x times x. So here you've got a pair of 3's and a pair of x's. Remember, if you've got a pair of 3's on the inside, it comes out as a single 3. So it would be 3. And you got a pair of x's that comes out as a single x. The leftovers in there would be the 2, the 3, and the x. 2 times 3 times x, of course, is 6x. And that is it. And I think I've seen just about everybody with that one. Number 2, we're maybe not quite there yet. Let me show you number 2. We'll talk about why this works. Number 2, we're going to do the same kind of thing. So this, I want to make sure you understand why. I'm going to do the prime factors again. So nothing different there. It's going to be 2 times 2 times 11 times how many x's? 5 of them. That's right. So times 1, 2, 3, 4. There's 5. Here's my pairs. I've got a pair of 2's, a pair of x's, and don't I have a second pair of x's? I've underlined my pairs of like factors. Ladies, have a good afternoon. See ya.
Guys, good luck at your swimming.
Thank you.
I'll be there.
All right.
Okay, so then here's how you finish this. This 2x was already there. 2 2's on the inside comes out as a single 2. What if I've got a pair of x's on the inside? How does that come out? Single x. And then don't I have one other single x that comes out? That pair comes out as a single. And then I do have some leftovers in there. I've got the 11, and I've got this other x. So it'd be 11x. And of course, 2 times 2 is 4. You all know that. If you have 3 x's being multiplied together, what does that mean? X times x times x. X to the what? X to the third, yeah. X to the third. And you've still got that root 11x. And there's your simplified response. I wrote that in a bad spot, sorry. So how are we doing? Saw a lot of good stuff. Here's what I'm seeing. I'll put it like this. I am seeing, you guys are getting it, but I'm also thinking it's Friday, which makes me nervous because what could happen over the weekend?
Forget it.
Some forgetfulness could creep in, right? So I'd encourage you to practice for sure. We got our first concept quiz of this semester on Monday. We're going to go over one little thing today, but yeah, if we were to take if today was a Thursday and we took it tomorrow on a Friday, I'd be feeling okay. I'd be feeling decent about it. Okay. All right. So do you guys have any last follow-up questions before we do our activity for the day?
Sure.
Okay. So here we go. If you would, we're not going to do a Desmos today. We'll do other Desmos activities next week. We're not going to do one today. All right. So we basically have one topic only, and it's right here. So if you guys would flip over in your notes. Actually, you know what? I'll make it simple on you. Would you get up and put your whiteboards back away? We're not going to use the little whiteboards, at least right now, anymore. So you can put those away, grab your notes packet. We're going to do this little section here. It won't take too long. Nice, Elf.
Thank you.
Hey, your notes, guys. Let's go. Write your notes out. These are the ones I just gave to you guys on Monday. Let's get those out. Let's get to this page right here. This is Unit 4, Day 3. Respectfully asking you to not text me. Is this a real emergency? So I'll email her and say, Mason is not allowed to be texting in the middle of class. Please don't expect him to respond. Okay? So I'll try to get that monkey off your back. Well, you're acting like you have to do this. So it's a monkey that you're not telling you you can't, and you're telling me it's not. So that's why I'm going to say, please don't respect him. I'm trying to do this thing. Because it's all just like not policy. This is a distraction. Now it's distracting to you. Now you're not getting a good distraction.
And I have my
You're okay with that? I'll be sure to mention that. I will be emailing you. Just make sure you
it's like so big.
No. You understand? Yeah. I want to make sure. Hey, y'all got your notes out? Good? Okay. So, for right now, I'm just going to say for various reasons that's up there. There are some historical reasons. So, pre-calculators, this was a huge deal, what we're about to do. And even post-calculators, now that we all have calculators in some form or another, it still is kind of a big deal, but it's a bigger deal for a different reason. It used to be that when we tried to divide by like a square root, very problematic. It just simply was not easy to do without a calculator. And now you say, hey, we got calculators, blah, blah, blah. Why do we need to do this? When you guys take geometry in Algebra 2, you're going to be working with one of the more applicable things that you'll ever study in math, like directly applicable, and that's trigonometry. I don't know if anybody does stuff like what I do, but I will like build things around the house. Like you guys know, like a climbing wall. I've like built a climbing wall in my basement because me and my kids, my wife, love to climb. I've got this training wall in my basement, and it's at an angle. And guess what I used to make this climbing wall and make it right? I used trigonometry, and trigonometry means that you'll be able to handle stuff like this. And so there's a number of reasons we study. Some of it's a little bit historical. Some of it is very practical. But for the moment, I guess I'm just going to say for various reasons. Those are kind of the various reasons. And here it is. We want to avoid leaving a radical or a square root in a denominator. And here's the terminology. If we do have a fraction and there's a radical in the denominator, we're going to say that the denominator must be rationalized. So this is the word that we're going to be using today. So rationalized, which is basically a fancy way of saying putting the fraction in a simpler form or a more basic form. So remember, the principle is you cannot leave a radical in the denominator. And the way, like the word we use to deal with that is we rationalize. So if you guys would look at A, B, C, D, E, of those, which of those do you think needs to be rationalized? So we'll just go one at a time. Just shout out, yes, it needs to be rationalized, or no, it doesn't. So what do you think about A? Yes or no?
Yes.
An extension of this question, you guys are hesitating a little bit. An extension for A would be, does it have a radical in the denominator?
Yes.
So if it has a radical in the denominator, do we need to rationalize?
Yes.
Yes. So I would say in A, we need to rationalize this. We need to simplify it through this rationalizing process. Okay, so part B. Do we need to rationalize part B?
No.
Why not? It really is that simple. There's no radical in the denominator, no square root down there. So there's no need for us to bother trying to rationalize the denominator there. C is a little tricky. Yes or no?
Yes. Yes.
Is there a radical down there?
Yes.
Really?
No.
Look more carefully.
Oh no. Well,
It's the square root of,
4.
and what's that?
2.
So technically it's root 5 over 2. So I would say we really don't have to. All we have to do is just recognize that the square root of 4 is 2, and we're done. There's no need to simplify it beyond that. How about D?
Yes.
Yeah, D, we're going to need to. That square root of 6 is definitely a radical in the denominator. And then how about E? That's definitely another yes. You've got a radical down there, and it's not a perfect square. So that would be our pattern there. Those are the ones that we would need to rationalize, and then the 2 that we do not need to rationalize. Okay, so that's basically the idea there is when do you need to do this? Can we take a look at what we do? Let's check it out. Let's flip over to the next page, and this is actually it for our class, running through these, 3 examples? Yeah, 3 examples. So here's how you do it. You flip over to this page. You've got 7 over square root of 2. Can you guys identify that as one that needs to be rationalized? It's got a radical down there. Okay. So I'm wondering if you can figure out, like, what could we do? Like, I've heard this, a way to think about this is you've got a rat down in your basement, that root 2. We want to get the rat out of the basement. That helps you remember it. That's great. But what do we need to actually do? Any ideas? I mean, I can just tell you it's... Oh, if we could turn that into a perfect square, we could do it, right? Kind of like that one we did earlier?
Yeah.
Okay, so square root of 2. What would be the first perfect square we could come to, like if we try to get that root 2 to be a different number, maybe a little bigger?
Multiply by 2.
Oh, okay, so if I multiplied by 2. Okay, so if I did times 2, wouldn't I have to do the same thing to the top? Well, let's be careful with this, because what is the square root of 2 times 2? No, it's not 2.
Would it be 4 in the square?
No, because you've got a square root of 2 is not just 2, it's square root of 2. Wouldn't this be, obviously the top would be 14, but wouldn't the denominator be 2 times square root of 2? So we really haven't, I think Anya is on, she's really close. Sebastian started us down the right road, and Anya has taken us really close. I think multiplying by 2 is not going to quite get us there, but we can. Any other ideas? We want it to be a perfect square radical. If I multiplied top and bottom by something that's like almost 2, it's like related to 2. Don't we, let me put it like this. In the end, to kind of go back to Sebastian's idea and where Anya was trying to take us, don't we want it in the end to maybe be like square root of 4? Because then that would be really easy to simplify and we're done. So what would I need to multiply the square root of 2 by to get square root of 4? There it is, square root of 2. So if I multiplied the top and the bottom, not by 2, but by the square root of 2, then I'm going to be able to get that radical out of the denominator. Here's what it would look like. 7 times the square root of 2. And then down here it would be the square root of 4. And like you all said earlier, square root of 4 is 2. So it'd be 7 square root of 2, all divided by 2. Can you see now that there's no more radicals down in the denominator? It's been rationalized. We're good. Making sense? Okay, so I think that you're going to find number 1 to be quite similar to what we just did. So if you guys would, please try number 1. See if you can figure out, it's a little bit different, right? But it's similar enough. See if you can figure out how you could rationalize and fully simplify number 1. These next two introduce a little bit more complexity because of the fact that you have the 12 and the 18 have some things going on. Let's see here. Ooh, so that's a little bit of a different way of doing it, but that's a really
52.
I really like that. I think that's cool.
54 is my square root of 1 to 18 multiplied.
Yes, sir. Okay. So I'm walking around seeing a lot of good stuff with number 1. Number 2 and 3, there's a little bit more to them. So what y'all multiply for number 1? You multiply the top and bottom by the same thing. What was it? Square root of 5. Yep, that's how you get up to that next perfect square. So if I multiply top and bottom by square root of 5, it's 9 root 5 over the square root of 25. And as I walked around, I think just about everybody had figured out, of course, that the square root of 25 is 5. And so then our final beautiful simplified answer would be 9 square root of 5 over 5. Guys hanging in there okay? Okay. So then we're going to do 2 and 3, and this will be our final 2 examples for the day. And I think what we'll end up doing at the end, I think you guys will have a couple of options once we're done with these 2. If you wanted to just work on WebAssign, I'll be okay with that. If you wanted to work on some of the square root simplifying stuff we've been going over, if you want to get a little more practice on that, we can do that too. So we can kind of split up a little bit as needed. Okay, so I think you guys can handle this. I'm feeling pretty good about this. I really am feeling good about this. So I would like to hear. I would like you to hear from one of your classmates what she did, because she worked ahead, and I think she did a really smart thing. This is where I would want you to go, but I wasn't sure if anybody's going to see it, so I think it's worth sharing. So Sydney, throw it out there. If you could, tell us what you did, maybe give just a brief explanation as to why you did it. Talk about number 2 here.
Well, I multiplied by the square root of 3, so then the bottom would be the square root of 36, which would come out to be 6.
Okay, so stop right there. So she said it really well. What do you think of her strategy? I wrote it up there on the screen. And why on earth would she pick, because obviously she saw that 12 times 3 is 36, but why would she want to get that radical to be square root of 36 instead of some other number?
Because the square root of 36 is 6.
Yeah, it's a perfect square, right? It's an easy perfect square to do. And so she was able to think, all right, well, 12 times 3, that would get me to a place that I want to go. Full disclosure, there are definitely other ways to do this. I like this way the best because it makes things simple, quick, right? So see if you guys can take what Sydney did here on number 2, see if you can finish it, and then see if you can apply the same sort of thinking to number 3. Okay? Stop. Like I said a second ago, there's more than one way to do this, and you have mostly done it. We're going to do a little bit more work. How you're starting to do it's really like this. It's just also really like this. This one would just a little bit of an issue with your last step. The square root of 140 is most definitely 12. It's not small. And so when you see square root of 144, basically what that's asking you is what number squared is 144? And your answer, of course, is 12. So it should just be 12.
It's like a ritual. It's like looking at yours is.
So once you erase that, so once you erase the square root of 12, you did. There's a little bit of simplifying that can still happen. So what would cancel the other? So this is those reduce. Okay, so dot. You clearly see she's heading for a slightly different place, and where that is, where it comes from, is basically how she can simplify it. Just so what you do with this 12, you know how we did the prime factor thing in the start class? So what is this actually? Should I just start as so you want to replace the 12 just 2 times 2 squared, and then you have to 2's. Does that make sense? Single 2. The 2 2's.
This is my I want that for myself. Like if somebody told that to me, I was like, well,
Still over 12, right? And then I'm going to let Sophia put the over 12 where she needs to be there. I'm going to let Sophia help you with the finish. See if you can use the same principle. I didn't say same number.
yeah, well, one of the other, like, no, you should use so rich.
Keep hunting. Keep hunting. No, I didn't small. That's a lot smaller than what you're. No? Keep looking. It's there. I don't want to rob you of the discovery.
Not read it right.
Hey, guys, let me finish up number 2 here, and then I'll give you maybe another minute or two to try 3 if you haven't already done so. Check this out. There could be some surprising twists and turns here. Please see what happens. So if we start off where Sydney left off, we get 3 square root of 3 over square root of 36. We all agree that getting to that root 36 was kind of nice, right? Yeah. Because when I come down here, I get 3 square root of 3, and the square root of 36 is just 6. And you might be tempted to leave it right there. And if you did, you don't have the wrong answer. You're just not all the way to a simplified form. If it said simplify completely, yeah. So isn't this just 3 times square root of 3? And so just the way that we simplify fractions, wouldn't this 3 and this 6 cancel to be a 1 and a 2? 3/6 is 1/2. So I would leave this as square root of 3 all divided by 2. Square root of 3 divided by 2. So that would be most simplified. And to be honest, like that's really all we're doing. We're just changing the form. So we do want to go to the most simplified form. Have you guys given number 3 a look yet? Yes. Let's make sure we're all on the same page. Using kind of that really awesome way of thinking that Sydney started us off on. Have you guys figured out what you would want to multiply top and bottom by on for number 3? Square root of 2. Yes. Excellent find. Why on earth would we multiply the top and the bottom by square root of 2? Actually gets you the same number we had 2 minutes ago, right? Yeah. So now maybe that you see that, see if you can bring it home. And maybe some of you didn't see that full simplification like we did earlier. See if you can bring number 3 all the way to a fully simplified version. Go ahead. Let's see here. Yeah, you got it. Or you could just leave this. Either way, I would take either way. It's good. Getting your Anya, what's up? We're there. We have arrived for the socks. Good. Good, yes. Life goals. Anyone?
Which one?
There's two. There's the route to NFL and the route to obesity.
Well, no, not the NFL, but like sports league. That's not good. No, one is like I become
Some of those guys are pretty.
Yeah. No, one is like I become so rich I could just buy my way into sports league, but I know it's fashion. And then just do really bad swearing and you know, or become so morbidly obese I can't
Where did this
I simplified it.
She did be pissed. She did be right.
So because 43.6 is 6. So like if you simplified this 6 with something down here, this should be changed, right? So what's the last thing?
Oh yeah. No, I was talking about like I either want to be so rich
Or obese.
No, I want to be so rich I can afford to just buy my way into like any sports league I want, and I just have no part in it. Like I'll just be an Olympic swimmer, but like really slow. Or I just be like so morbidly obese I can't get on that. Those are my two goals.
Yeah.
Yo, be alive, man.
Am I going to one?
Yeah.
What?
Yes.
Is he back? Is he back? Is he back? Is he back?
You back you never lose the weight.
You look like you.
Yeah,
You look like
That's
you're
when you die hard.
Matter, I came out of the seat.
I do sometimes.
Give me a break. Oh. No worries, dude.
Die hard.
6 root 2 over 6. 6 over 6.
Oh, you're about to
And then get a bunch of subscribers. That's because you die.
I should be a sophomore too. No, Sasha, I could be a sophomore too. Really? Leave all of it. No, you're. You look like.
All right.
You look like you're 12.
So guys, let's wrap this one up. Okay, 6 times the square root of 2 is simply 6 times the square root of 2, but the denominator ends up being the square root of 36. And that was a very smart number for us to go for, right? Because we know the square root of 36 is 6. So it'd be 6 times the square root of 2 all divided by 6. And the 6's then would divide out to be a 1. And you just end up with a final simplified answer of square root of 2. So here's what I want to do. We've got about 6 minutes to go. Earlier I said we have our concept quiz on Monday, but we don't even have class on Monday. It's on Tuesday, right? We don't meet on Mondays. So 2 things about that. Number 1, if you would like to drop by maybe at lunch on Monday, I'll send you an email. I got to look at my calendar. That might happen, or even before school. I'd be happy to, what I'm trying to say is whenever our schedules work together, I'd be happy to work with you to get you practiced up if needed for that. But I think we should finish our class by doing some review of that. So if you all would get up, we'll do 1 or 2 of these. We'll just see how it goes. Find a spot at the board, and we'll do a little bit of practicing.
Why are you only giving me 8 years?
Because
This is not a
Does it take that long?
wait, and then the heart like
Okay, it's up there. You can erase anything that's on the board. You can erase anything you need to.
goes and it like freaks out because it's so big.
Actually, hey, Trevor
And then Sebastian.
and Bray and Noah, would you guys come to the front? I don't want you to erase that because I'm going to use that after school. If you guys could just use the front, there should be plenty of room. Okay, as long as you don't erase my stuff.
I won't erase.
You guys can erase the stuff right in front of you. In fact, I'll do that for you just so that you have a little bit of room. Okay.
Oh wait, is it that one?
Yep, it's up on the screen. Square root of 40x to the 5th. Square root of 40x to the 5th. Once you think you have it, just turn around and let me know, and I'll check for you and see how it went. All right, Sophia, you got it. I'm going to put a second one up there for those that get done sooner. Sydney looks good. Yep, Anya looks good. Julia, perfect. Great. Nice job. Ray, where are we? Where's your answer? I can't quite see your answer. There it is. Yep, you got it. 2x squared root 10x. Yep. Should be 2x squared. We have a pair of x's and another pair, so that would give us 2 on the outside. Okay, that is right. That would be right. Yes. 2x squared root 10x. Yep, that's good. Okay, so once you get done with number 1, see if you can move on to number 2. Sebastian, where'd you go?
Let's go.
That's good. Noah, you got it. Where are we at here? So let's see here. You know what? No, that's good. That's good.
So.
Okay, so I agree with the 2. Sorry, hang on just a second, Chase. So there should be another 2 left over in there, right? You got that extra 2? So there should be a 2 there. You get the 2 x's out, so you had a pair of x's, a pair of x's. Don't you have 1 left over x? No, you got it. Thank you. Who was saying? Somebody was saying my name. Yes, ma'am. Let's see here. It's really close. It's this.
Oh wait, the x. Sorry.
Oh, but the square root of 9 isn't 9. Square root of 9 is 3.
Oh.
Oopsies, I read this.
It's 2x.
2x root 5x over 3. Yeah.
Oh yeah, we did it.
Okay, where are we at? Yes, sir. Yeah, that's perfect for number 1. Exactly right. Okay, what do we got? We got 2x root 5x over 3. Yes, that is correct. Nice job.
Can I see here? Would the 2x, would this be attached to here or would it just be to the side?
Say that one more time.
Like, does the answer have to be like this or like that?
Either is perfectly acceptable because technically, if you wrote it this way, isn't this just over 1?
Oh.
And then it would just be times, and that's the same thing you've got there. So that's good. Hey, there we go. That's good. Whoever that one is, that's good. Okay. Let's see here.
It's 2x squared, 5x.
So I'm writing the answer to both up there, putting them in a green box.
Oh. I don't know how to do number 2.
So hey, check out number 2. Hey, you guys, if you are done and good to go, head on out. I'll do number 2 here real quick. Check out this screen up there. I'll just talk to you while you're looking at the screen.
So you just do the square root of 9, which is just 3, and then that's...
Yeah, so you basically do the square root of the top and the square root of the bottom. And of course, the square root of 9 is 3.
Okay.
So this will give you 3. And then the top is just like what you've been doing, right? You'd make it 2 times 2 times 5 times 3 x's.
Yeah.
And then you get the pairs out. So that's just like what we've been doing.
So it'd be 2x.
But the key is to split it first.
Yeah, so it'd be 2x root 10x.
Root 5x. Because there'd be a leftover 5.
Okay.
Yep. You betcha. Hey, great job today, you guys. See you later.